In today's video of Physics and Sports, we are exploring how physics is a fundamental reason of how baseball works.
For today, we are using games from the MLB to help show this.
There are 5 main Physics 1 concepts that are very applicable to the game of baseball: kinematics, dynamics, momentum, energy, and gravitation. Kinematics is the study of motion and can be used to describe the acceleration of the ball, direction of velocity, and can be used to determine the path of the ball before and after it's hit. Dynamics involves the forces and torques applied to the ball that cause motion. In a baseball sense, dynamics is crucial in determining the motion via the forces applied to the ball during pitching, hitting, and fielding. Momentum can be used to describe collisions between bat and ball and glove, and initial torques applied to the ball when it is thrown. Energy is important when finding the max height after a ball is pitched and velocity at any given height. Gravitation is used to determine accelerations due to gravity at any given stadium due to distance from sea level that is instrumental in determining max height and distance where a ball will travel.
Kinematics describes the motion of the baseball without considering the forces causing it. It helps predict the trajectory of a pitched ball or a hit. For example, the initial velocity and angle of a pitched ball determine where it will cross the plate. And similarly, a hit ball's path can be analyzed using these principles.
Dynamics involves the forces that cause motion. In baseball, the force applied during pitching, hitting, and fielding are essential. Newton's laws of motion explain these interactions. For instance, the force the pitcher exerts on the ball determines its acceleration, hence F equals ma. When a batter hits the ball, the force of the bat changes the ball's velocity.
Momentum, P equals mv, is critical in collisions, like when the bat hits the ball. The conservation of momentum principle states that the total momentum before and after the collision remains constant in a closed system. This helps calculate the ball and bat's velocities pre and post impact and determines the result of the at-bat. The angle of the bat path and collision can help determine the flight of the ball post-collision.
Energy in baseball involves kinetic energy and potential energy. When hitting, the bat transfers kinetic energy to the ball. As the ball flies, it has both kinetic and gravitational potential energy affecting its motion and height.
Gravitation pulls the baseball downwards, causing it to follow a curved trajectory when thrown or hit. This force affects vertical motion, like when a ball reaches its peak height and then falls. Understanding gravity helps players predict the ball's landing spot.
Air resistance applies a force opposite to the direction of the ball. This force is called drag. Drag opposes the motion of the ball in the air. If not for drag and gravity, a ball will keep moving on in the air at a constant velocity and never stop. The equation for drag is drag equals CD. The drag coefficient times 1/2 of the air density R times the velocity squared, V squared, times the reference area A.
Air density can also affect the air resistance of the ball. For example, due to the altitude in the Colorado Rocky Stadium, as it is a mile high, the air density is less. Since it is less, and air resistance correlates with air density, drag on the ball is also less, which results in more home runs occurring in the Rocky Stadium. While in sea-level stadiums like Yankee Stadium and Oracle Park result in less home runs due to higher air density. At terminal velocity, the magnitude of air resistance is equal to the weight of the ball. Since the forces are opposites, the net force on the ball is 0 and the velocity of the ball has become constant.
In baseball, the principles of kinematics, dynamics, momentum, energy, and gravitation are crucial to understanding the game's physics. In today's baseball, StatCast is used to determine new sabermetrics like bat speed, exit velocity, home run distance, pitch speed, and many more. Air resistance and density of the air help us determine the kinematics, dynamics, and the motion of the objects using physics.